All right, so the statistics on our nozzles, and I'll look at both of the nozzles that we carry now. Is the 15/16 on our 1 3/4 lines, and then our TFT 175 constant gallonage flow fog nozzle. There's, as you can see here, if we're pumping 50 psi, which is what we should have at the nozzle, that gives us approximately 185 gallons a minute, which equates to a little over 3 gallons per second. So imagine 3 gallon milk jugs. We're doing that every single second that we have that nozzle open all the way. Now, along with, and this is one of the conversations that goes back and forth when you're discussing smoothbore or fog nozzle, is nozzle reaction. Where some will say that they feel more nozzle reaction from a smoothbore than what they do with a fog nozzle. You and I both know the main reason for that is because the smoothbore nozzles get pumped too hot at times. They're getting over pressurized. So the nozzle reaction for a 15/16 smoothbore pumped correctly is about 69 pounds, which is one person is capable of handling. TFT 75 psi, 175 GPM, we get a nozzle reaction of 77 pounds, but we're actually getting less gallons per minute. It's just the physics of how that works. And for those of you who want to check my math, there's the equations that I used at the bottom of that slide.
One of my favorite analogies with this is, because we're talking about interior firefighting, is horsepower and traction. I mean, this is the perfect demonstration. So 50 psi, 185 gallons per minute, you can see why this would be the preferred choice for this department. You have a flow rate of 3 gallons per second and a nozzle reaction of 69 pounds. When you overpump that, you can see you're not gaining as much in flow, but you're having a significant compromise on your reaction. The flow is the horsepower, the reaction is your traction, basically. And when we're going interior for firefighting, we want to have good traction. If we're on the outside, the Master Stream, that's the drag racer, a ton of power in a straight line, just delivering that big hit. But we have to work around couches, we have to work down hallways, we have to work into rooms and upstairs. We need a little bit more of an all-wheel drive.
Talking about our 2.5-inch line stats, with the comparison between the 1 1/8 smoothbore and the TFT 50 psi 250 GPM constant gallonage nozzle, and I want to try to give us an apples for apples comparison, so we have a fair way of looking at this. So to achieve the closest thing to 250 gallons per minute on the smoothbore, you have to have a nozzle pressure of 45 psi. That gives us a nozzle reaction of 89 pounds, which is the same as the TFT nozzle. Realistically, though, if I can get more water, I should do that. So if I just go up a little bit of pressure to 50 psi, which is what we do for the sake of simplicity, that takes me up to 266 gallons per minute, or 4.5 gallons per second, and my nozzle reaction is 10 pounds more. Another part about the smoothbore nozzles, as far as it being able to tell us the quality of the flow that we have, I took some screenshots from another video, and I put the reference on the title video, or the video that I took this from was called How Kinks Affect Your Fire Flow System. It's another brass tacks and hard facts video, episode 35, and there's a web address if you want to go watch it yourself in its entirety. But one of the things that the instructor bringing up, it shows different kinks, and he does more than what I'm showing here, but I'm just using it to prove a point. So we'll put it like in a Z kink, which is common type of situation we can find, is that if we don't flake out a triple load the right way, or if we've made multiple turns in the house, or various things. But it gives us an apple to apples comparison. So up here in the upper left, this is a 150 at 50 GPM fixed gallon combination nozzle. With the two kinks in it like this, it flowed 82 gallons per minute. So anytime we get below 100 gallons a minute, or really below 125 gallons a minute on an interior tack, it should be cause for significant concern, as far as I'm concerned. We should again, we call it a firefight, but really I want it to be a fire whipping. I don't want it to be close. I want us to knock it out as fast as we can. So we look at the 150/50 fixed gallonage at 82 gallons per minute. The 15/16 with 50 psi at the nozzle with the same kinks, it still flowed 140 gallons per minute. So that's significant, and that should make a difference in what we're doing. So some would say, well, it's because we don't have the back pressure because we're only pumping 50 psi to this. If we had higher pressures, it would resist the kinking. Well, lucky for us, they included that in the video. Here is a 150 gallon per minute nozzle at 100 psi automatic. They put the kinks in there, and it went down to 108 gallons per minute. So even with the higher back pressure, or the ability to or the capability of resisting kinks because of the higher back pressure, it still significantly reduces the flow. And going back to the simplicity part of it, both of the fog nozzles, whether it's the fixed gallonage or the automatic nozzle, it's not that they're doing it with an evil intent, but they're deceptive in a way, because you can't tell that the line flow is restricted as easily as you can with the smoothbore nozzle. So you might have the impression that I'm kicking butt here. I've got a good stream, but if you've got kinks like that, it is restricting the amount of flow that you're getting out of that line. If that occurs with the smoothbore nozzle, you can feel it, you can tell it, you can hear it. There's all of those other indications that come about. But even with the kinks, you see that we still have a very effective fire flow.
There's two key things being hit on here, and one is that 150 at 50 to that 15/16 example. Basically, what you are is you're creating a safety factor. We the kind of the national standard on minimum fire flow for interior firefighting is 150 GPM. Certainly, we don't need 150 GPM on every fire, but we're building in that safety factor. If kinks are going to happen on the fire ground, if we're not accounting for them, we're not creating a safety factor in it, then we are automatically going in below our flows. The other thing I'll pass on, and it's kind of demonstrated here, is we have a belief, again, back to theories and showing things, we have a belief that higher pressures resist kinks and higher pressures prevent kinks. And that is true to a point. And I'll kind of give it to you in this analogy, a straw versus a garden hose. Consider a straw, like a McDonald's straw, 100 psi line. If I try to kink it, it's going to fight it for a while, but then that kink becomes complete. You're going to get a very complete kink with it. A garden hose is lower pressure. It's more pliable. I can bend it a lot, but I can create loop after loop after loop because it's a pliable line, and the water's moving through it at a lower velocity, so the turbulence is lower. So you have I guess less impactful kinks than complete kinks. The other part that we'll get into now is, while we're talking about kinks affecting our flow, the other place where you see reduction in flow is at the bail. And again, with the smoothbore nozzle, for it to be that solid stream, it's all the way open, full flow. In a fog nozzle that has that option of a straight or a solid, or straight or a fog stream, I can turn it to a straight stream and have it at half bail, and it will still give me that straight stream. So Chief will now kind of demonstrate that. Like, we know very clearly when a smoothbore nozzle is operating at half bail. Half bail is half flow. It's difficult to understand as a observer, either interior or exterior, when a fog nozzle is being operated at half bail, because that stream is always broken up and always recollected. again, it's options versus variables. You know, the fully open, it's a quiet, steady stream. You can see the cohesion in it. And as that backup person, this is what we want to hear. If we hear chatter, that person has the nozzle half open. We need to ask them, do you need help? You know, are you good? But we should have a smooth operation.